Hi, my name is Valerie and I'm a bioengineer. A what? A bioengineer. Let me explain. Let's start with what is an engineer? Engineers are people who design and build things to solve everyday problems. This is how I see it. Scientists want to know how the world works, and engineers use the knowledge that scientists gather to solve problems and make the world a better place. There are a lot of people who do a little bit of both, but in general that's what I think the difference is between scientists and engineers. There are a lot of different types of engineers. For example, civil engineers. They build bridges to solve the problem of how do we cross this river, for example. There are also electrical engineers. Some electrical engineers are solving the problem of how do we store energy, and they invent things like batteries. There are also computer engineers, which some computer engineers have made sure that you can watch this video on YouTube. There are chemical engineers, mechanical engineers, and bioengineers. One thing that all engineers have in common is how they solve problems, their way of thinking. They use something called the engineering process. This is a way to approach a problem so you can come up with the very best solution. If you're interested in learning about this engineering process, I would highly recommend watching this video. But briefly, in step 1, you identify what your problem is. For example, here's a river, how do we cross it? In step 2, you brainstorm ideas of how to solve it. Maybe we can use a ferry to cross it, or build a bridge. In step 3, you design your solution and you build it. What is important is step 4. That is, testing your solution, see if it actually works the way you think it does. Is this bridge sturdy enough to let people pass? And keep on improving on your design. Engineers often have to go back and redesign things multiple times before finding the best solution. But I'm not just an engineer, I'm a bioengineer. Bioengineers use this engineering process, this engineering way of thinking, to solve problems related to living things. This doesn't mean that we build bridges out of rabbits, though there are many different types of bioengineers, just like there's many different types of engineers. There are people who are working on improving food, or energy, or creating medical devices like prosthetics, working on DNA, or bioinformatics, or tissue engineers. I guess that's what I do. I'm a tissue engineer. I work on something called organ on a chip. Wait, let me explain. Chips? Not potato chips, but little devices on which we can grow mini organs. Organs are parts of your body, like your heart is an organ, lungs is an organ, your kidney, your liver, those are all organs. And your organs are made up of tissue. Not tissue you blow your nose with, but tissue is kind of like the fabric that makes up clothes, but instead of clothes, it's the tissue makes up organs. And your tissue is made up of different cells, a little bit like strings making up fabric, or building blocks making up a house. What we do is we take little parts of tissue, or a few cells, and put them into this little device. We then give these cells the right food that can just flow through right here, the right temperature, the right environment, so they grow out to be a little mini tissue or a mini organ that we can use for a variety of experiments. So we can grow a mini heart on this chip, or a mini lung, or a mini kidney. At my company, what we do most is grow little parts of a kidney on a chip. The kidney is a very important organ in your body. It takes care of filtering out a lot of toxins. For example, toxins that you get through medicine, or from eating, or from breathing the air. And sometimes these are very bad things that are not good for us, so our kidneys make sure that it gets taken out of our body and then we pee it out. So one common use of this kidney on a chip is that people can use it to test if new medicine is safe for our body, if our kidney would be able to filter out all the bad stuff and make sure that it doesn't harm our kidney or our body. So when researchers invent new medicines, they have to make sure that it's safe to use and won't make the person sicker, because medicine is to make someone more healthy. So they first have to learn how the drug works and try it out in a lab. Quite often, these lab tests involve trying out this medicine on animals, like lab mice. But testing new medicines on animals takes a lot of time, costs a lot of money, and doesn't always predict how well a drug will work in the human body because animals work different than humans in some ways. So, a lot of people, bioengineers, tissue engineers, myself included, are working on this new technology, organs on a chip, to make sure that we don't have to use as many animals when developing new medicines. So if we think about the engineering process, let's use my work as an example. Step 1, what is our problem? Let's define the problem. We are trying to make sure that new medicines are safe to use in humans. Step 2, let's brainstorm some ideas. We can test that in a human, but if it's not safe to use, it might be really bad, and we don't want to do that when we're testing a new medicine. We can test it in animals, but as I said, this costs a lot of money, a lot of time, it's not ideal. Or we can make these little organs on a chip and test a new medicine in there. And step number 4, we build our solution and we test it out. And that's exactly what we're doing right now. We build these little organs on a chip and we test it and we let people making drugs test it. So now we're trying to make sure that they work the way we want it to. That's the beauty of the engineering process. We can always go back and redesign and remake our product and make sure it's the very best solution. Now you know what an engineer is. An engineer is someone who uses this engineering way of thinking, the engineering process, to solve problems and make the world a better place. Now you know what a bioengineer is. A bioengineer is someone who does this engineering to living systems. And now you know who I am. My name is Valerie, and I am a bioengineer. If you have any questions, please let me know, and I'll do my best to answer them. Thank you for watching.